Now, I'm sure you've all heard of holes before, but have you heard of black holes?
They're tunnels that not even light can escape.
You may be thinking, who's that bombshell blonde in the first scene who captured my heart in a simple matter of a few seconds? But instead, I'll answer the question of, what is a black hole really? Black holes are a type of stellar remnant, the bones of a dead star, so to speak. Black holes are formed from stars with giant masses. Not just any old star turns into a black hole. Black holes are formed when a star with a mass bigger than 20 times the mass of the Sun has a supernova. Its mass is so great that it compresses its core until the core's internal pressure can no longer support itself and it collapses. This totally collapsed core is known as a black hole and has strange properties.
The life cycle of a black hole begins with an interstellar cloud. After that, the interstellar cloud transforms into a protostar, and from there, the protostar grows into a main sequence star. After it stayed on the main sequence for a while, it then turns into a red giant. After a red giant can no longer use nuclear fusion, it turns into a black hole if the mass of the star was large enough.
Two hydrogen atoms collide to form a deuterium. This deuterium then collides with another hydrogen atom to form helium. This helium collides with another helium to form helium-4. This helium-4 then turns into carbon. The carbon turns into neon. The neon turns into oxygen. The oxygen into silicon, and finally silicon into iron. Once the star reaches the stage of iron, it can no longer use fusion and has a supernova. After a main sequence star burns up the majority of its hydrogen fuel, its outer layers begin to compress, which makes the core so hot it begins to fuse helium. The heat from the core makes the outer layers expand, and the star becomes a red giant. Mass is what determines whether a star turns into a white dwarf, a neutron star, or black hole. Mass determines the core temperature because more mass means more gravity, and the gravity compresses the core, heating it. The heat enables it to fuse heavier elements and thus creates a supernova. When a very high mass star goes supernova, the core is so dense that the core completely collapses and turns into a black hole. The average density of a black hole is 4.4 times 10 to the 13th power grams per cubic centimeter. A black hole is so dense because it's the mass of a gigantic star compacted into a tiny area.
There are three types of black holes: miniature, supermassive, and stellar.
Stellar black holes are the traditional type of black hole, forming when a star with over 20 solar masses has a supernova and collapses. Supermassive black holes are gigantic and can contain up to the mass of 1 billion of our suns, and they likely exist in the middle of most galaxies, including our own. We don't know that much about how they form, but it's likely that they came from galaxy formation. No proof of miniature black holes has ever been discovered. They would have a mass smaller than our sun. It is theorized that they would have formed after the Big Bang because the Big Bang was supposed to have compressed the small stars enough to turn into black holes. Black holes are also connected to a theoretical object called wormholes. Wormholes are a long tunnel with two black holes at either end. If you were to enter said wormhole through any entrance, you would come out the other end in a completely different time entirely. Another fun fact about black holes is that they have gravity so strong that not even light can escape their hole. Fun fact, black holes are in fact not actually black. Oh snap, what do you think about that? I believe that our sun will become a white dwarf stellar remnant. This will take about a total of 12 billion years. This is because a star stays on the main sequence for an average of 10 billion years, is a red giant for about 1 billion years, spends about 100 million years as a yellow giant, 10 million years as a Mira variable, 10,000 years as a planetary nebula, and then transforms into a white dwarf.